Maybe. Are you recording or blinking standby? There we go.
All right. Let's forget 0.53 for a second. Let's use a nicer number. Give me a nice number you want to play with.
7.
7? 7 sounds good. 1's boring, unfortunately. We could use 1, but you'll see why 1 wouldn't work in this game. 7. Love it. 7. What's 7 to the first power?
7.
7. What's 7 squared?
49.
49. What's 7 cubed? 300-ish.
343.
Thank you. 343. What's 7 to the fourth? 2200.
2401.
There we go. All right. How do you know this?
Calculator.
Oh, okay. Good. Good. But you know what you to put into the calculator, correct? So how did you know that? What does 7 to the fourth mean? 7 times 7 times 7 times 7. Kill it. Very good. So you have this idea of what an exponent means. It means use that number as a factor that many times. Now, at some point in your mathematics careers, you learn about negative exponents too. You might hate them, that's okay. So you had 7 to the negative first power, for example. Remember what that is?
0.07.
Why 0.07?
Because you're, I forgot why.
It's okay, brother man. It's all right. If you type, go ahead, in your machines, please type 7 to the negative 1 power. In case you need to know what a to the is, it's the little caret above the division sign. 0.142857142857142. It's one of those magical decimals that appears. It goes on forever. It's 0.14285714285714285 forever. It's like Rain Man right now. I apologize. What is that decimal? Please, Alicia.
It's negative 110.
Wait, say that again.
Huh?
Say that again.
Negative 1?
What about the negative 1? What does it mean?
It said negative 110.
But it's 0.14287.
Yeah.
14285714285. What? Say that again. It's 1/7. It means the negative exponent, by definition of how it's used, and you're about to see why it does this. I know you all learned this at some point, you probably forgot it too. You're about to see why it does what it does. It's you take this number and make it a reciprocal. It's 7 to the negative 1. The negative means make it a reciprocal, and then look at this and make it negative. Go ahead, put, not negative. The negative makes it a reciprocal. Put 1 divided by 7 into your machine. What do you get? The same difference. I love that word. I love that phrase. The same thing as if you put 7 to the negative 1 in there, because that's what 7 to the negative 1 is. It's 1 over 7. Karen, answer that question.
Well, okay, so what if you have more than negative 1?
Well, let's look at 7 to the negative 2.
Okay. You do the same thing, right?
You do the same thing. It's still 1 over, but 1 over 7 squared.
Oh.
Oh, yes, ma'am. So it's 1 over 49.
Okay.
Yes. 1 over 49. Yes. Very nice. 7 to the negative 3 would be 1 over
343.
well, 7 to the third, which is 343. So 1 343rd. 7 to the negative fourth would be 1 over that, which would be 1 2401st. So now what I want you to do is I want you to look for the pattern. Because we skipped a number in here, didn't we? Didn't we skip a number?
0.
Yes, we skipped the problem child, which is the 7 to the 0th power, yes? The question is, what goes right there? Well, let's not plug it in by memorizing it. Let's plug it in by understanding how we get from one to the other, yes? How do you get from 2401 to 343? You divide by 7. This is 7 to the 4th. That's 7 cubed. If we're going backwards, you would just divide by 7 to get to that one, yes? And we went down, the exponent went down by 1. So this exponent goes down by 1, this divides by 7. Let's keep it going. How about 343 to 49? Divide by 7, exponent goes down by 1. So minus 1 here, divide by 7 here. Keep going. 49 to 7, divide by 7, exponent down by 1, negative 1. Or subtract 1, I should say, not negative 1, subtract 1. Skip the 0 for a second. How did you get from 1/7 to 1 over 7 squared?
Divide by 7.
That's still dividing by 7. It's you might think it was multiplying by 1/7, but that's still dividing by 7. That's the definition of division. So you divide by 7 right here. And then we went down by 1 with the exponent, yes? So it stands to reason that since we're going down 1 here and then going down 1 here, the number we put in right here has to continue this pattern. So, let's continue. Sorry, Taylor, I was a little bit loud.
It's okay, I'm just not quite like that.
Well, you're going to be.
I am now.
7 divided by 7? 1. 1 divided by 7? 1 7. Well, there you go. That's why anything to the 0 power is 1. To continue the exponential pattern. Was it special that we used the number 7? Did I stop Brandy as she walked in here and say, "We can't say 7 because it works for 7"? Did you hear me say that? My God, no! I said, "Hey, critters, how you doing?" My exact words as I walked in the room. Nothing about Brandy picking the number 7. If we use the number 2, would this work? Of course it would. You get different numbers here. 2 to the 4th is 16. 16, 8, 4, 2. 1, 1/2, 1/4, 1/8, and so forth. That's why we didn't want to use 1. 1's boring. 1, 1, 1, 1, 1, 1, 1, 1, 1. I mean, 1 still works, but it's boring. It doesn't tell us anything. You gotta be careful. You gotta be careful. You can't use 0 as a base. You can't do 0. We're not gonna worry about that in this class anyway, but 0 to the 4th is 0, 0 cubed is 0, 0 squared is 0, 0 to the 1st is 0. 0 to the 0 power? It's called indeterminate. Mathematics is weird. You can ignore that. It doesn't have any connection to your world anyway. So you just let it go. Let it go. Focus on real Focus on a real basis. Focus on real bases, not ones that create mathematical oddities. You also don't want to use negative bases. Like you don't want this to be like a negative 2 to the 4th, negative 2 cubed, negative 2 squared, because that gets weird because they alternate positive and negative, which is not something you encounter in your lives. You encounter positive bases like taking a drug and letting the half-life flush through you, or going to Vegas and watching the roulette wheel. That's positive bases. You'll see all that connects. So, taking that over there, sorry about that little tangent lesson, but I think it explains why your y-intercept is 267, doesn't it? Because if x is 0,